work is
Force
not only the
into displacement.
force times the displacement, where the force is the intensity factor and
Displacement is
displacement is the
capacity factor.
capacity factor. So yeah, and this is also called as the mode of transfer of energy, like we discussed. Mode of transfer of energy.
Yes.
Now, the work done by a system. What will be when the work is done by the system? It will have a sign convention. When the work is done on a system, how will it be calculated? What will be its notation? Works. Before that, intensity factors and the capacity factors. Let's see some examples. Pressure, will it increase in terms of capacity or intensity? I'm applying
Intensity, sir.
intensity. Yes. So pressure is what?
Intensity factor.
Intensity factor. What about volume?
Capacity factor, sir.
Yes. You see the change now?
Yeah, yes, sir.
Volume is going to be a capacity factor.
Yes, sir.
What is work then?
Pressure into change in volume.
Work is mechanical work. You can call it as any physical work. Yeah. Physically, there is a displacement taking place. So we call it as a mechanical work, or we can also call it as, since it is intensity part and the capacity part, the work is W is equal to F into dx, isn't it? F
Yes.
dx. Where F is your intensity and this is your capacity. It is also called as intensity in terms refers to the pressure and capacity refers to the volume. So the work can also be mentioned as pressure volume work. Makes sense? Why?
Yes, sir.
Because it is in terms of intensity and capacity. We can also call it as a
Pressure volume.
pressure volume work, which is referred as PV work. V for pressure, V for volume work. Alright?
Yes, sir.
Okay. Now, we said work is a path function because it involves both the state as well as it follows a path.
Yes, sir.
Rather, it is not a state function, it is a path function. Work is a path function and not a state function. So earlier we mentioned, which is also affected by path. That's where we told about work. But
Yes, sir. Work and heat.
yeah, but work is a path function mainly, but not a state function. So what happens? It depends upon the path which is followed. Let's try to understand this a little more deeper. So what happens to the work done on a system? So I have a system. Okay. I do a work on the system. The work is done on a system. What does it do to the energy of the system? This is our system. So in this case, the energy of the system is going to increase. We see an increase in the energy of the system because it takes the energy from externally and stores with it.
Yes, sir.
Right? So when work is done on a system, okay, it will be positive or greater than 0. On the other hand, when the work is being done by the system, how will it be?
Sir, on a system means the surrounding does work on the system like that, sir.
Yeah, for example, you are heating it. You are heating a system. what happens? The energy increases inside the system. Energy of the system increases, isn't it?
Yes.
What is the energy in this case? Kinetic energy of the molecules
Yes.
when you boil liquid or when we are cooking or anything. So work done by a system, work is going to be what?
Negative. Loses energy.
Yes. The work done is going to be negative or less than zero. So exactly. So it loses energy here, whereas on the previous case it gains the energy. Make sense?
Yes, sir.